Hello, my name is Steven Morales, and I'll be talking about the career of electrical engineering, its career subfields, and its real-world applications. So what is electrical engineering? Electrical engineering is a major branch of engineering that dates all the way back to the 19th century. Some people that have contributed to this field are James Maxwell and Nikola Tesla. This field is about designing and testing electrical equipment and systems and combining that with scientific and mathematical principles to be able to solve world problems. It's known as a very broad and diverse field because of the different ways electricity can be used with technology. So how to become one? So to become an electrical engineer, you need a bachelor's degree in that field or in a related field at the minimum, and it has to be from a school accredited by the ABET program. Up-and-coming engineers also need to pass the Fundamentals of Engineering exam to become licensed as engineers. So salary and job growth. With about 190,000 electrical engineers, they're expected to grow at a rate of 5%, and that doesn't include the electronics section. This means that about 9,000 jobs will open up from 2018 to 2028. Engineers are known to make high salaries, and median salary for an electrical engineer is $80,000 to $90,000. The maximum is around $150,000. So career-wise, electrical engineering is extremely broad, and I'll only be talking about two of the subfields here because there's way too many to talk about. But the first one here is power engineering. Power engineering is one of the oldest subfields in electrical engineering. The field generally focuses on generating, transmitting, and distributing high electrical power to the public. This means that engineers that specialize in this field have to work on large-scale projects. These projects include the power grid, solar panels, and wind turbines. Electrical systems and equipment are designed to be able to utilize more power, like a transformer, for example. And depending on what project it is, the power station will use whatever it's given to generate electricity. So the wind turbine, wind, solar panels with the sun. So communications. Communications engineering is mainly about transferring and manipulating signals. Engineers in this sector can work in a variety of places, which include space stations like NASA, telecommunications like your phone carrier service, and satellites. In more specific terms, communications engineers design electronics that are able to transmit signals, and they take into account the weather, building obstructions, and other signals because those three things can affect the signal's path, and it can, maybe they won't allow it to get from point A to point B. So problems that electrical engineers face. One of the main issues that they face is rapid development of technology. Technology is constantly becoming more faster and better in a shorter amount of time, and engineers need to stay on track of it in order to maintain control over it. Another problem is the counterfeit components in the electronic supply chain. These counterfeiters use cheap and fake products and components to basically steal the businesses and engineers, consumers, and money. So some solutions to the innovative problem is that engineers generally keep track of the past technological trends and they try to start like predicting, I guess you would say, like when new technology should be coming out. And they also start a culture of preparation so any new technology can be noticed as early as possible. For the counterfeit problem, engineers have designed these tracking devices on electronics to be able to track down these counterfeit products and components and trash them. Why would anyone want to become an electrical engineer? Well, no career is made specifically for everyone, but electrical engineering and engineering in general provides many benefits for both the individual and the society. One of our newly added basic needs is electricity, and it is easily visible when you look at the world around you. Electricity is able to be used in our homes and businesses because of power. All of our technologies need electronics to be able to function. I wouldn't be able to deliver this presentation to you if it wasn't for telecommunications, and our computers and operating systems would be non-existent without computer engineering. So engineering itself is just a service to the public, to the people, and it helps improve lives. It helps improve lives, and it helps propel society into the future. It's very important in our day-to-day lives, and it's not noticeable, so we don't really notice it.